In this video, I will consider one numerical on loop analysis or mesh analysis. Find I/O using mesh analysis for the circuit shown below. This is the given circuit. We are supposed to calculate the value of I0 using mesh analysis. So here we can observe that we have three loops. This is one loop, this is second loop, and here we have three loop. Let me assume current in this loop is say I1. Let current in this loop is say I2. So anyhow current in this loop is I0 is flowing. I will take it as I0. So now here we can observe that 3I0 is a current dependent current source which is dependent on current I0, where current I0 flows here. So if current source is between two loops, then we have to analyze that loop, that current source first. So let me analyze this current source. I can write 3I0 is equal to, so I2 and 3I0 are in same direction. I can write it as I2 minus I1. Let me call it as equation 1. So now after analyzing the current source, we have to assume that this current source is removed from the circuit. So if we assume that this current source is removed from the circuit, then we can have only a single loop, this entire loop. So this entire loop is known as super loop. Now we should apply KVL to this super loop in this direction. That is, apply KVL to super loop. That is, let me start from here. That is 60 is equal to, voltage across this is 10 I1 minus I0, because in 10 I1 and I0 is flowing. Then current will flow through 2 ohm resistor. That is, voltage across 2 ohm resistor is 2 I2 minus I0 plus current will flow through 8 ohm resistor. That is 8 I2, because I2 current flows in 2 ohm resistor and 8 ohm resistor. Let me simplify this. That is 60 is equal to, we have 10 I1 minus 10 I0 plus 2 I2 minus 2 I0 plus 8 I2. Let me simplify further. That is 60 is equal to, here we have 10 I1 minus this 10 I0 minus 2 I0, that is 12 I0 plus here we have 2 I2 plus 8 I2, that is 10 I2. So from this expression I can write, I1 is equal to I2 minus 3 I0. So now let me substitute I1 value in this expression, that is I2 minus 3 I0. 60 is equal to 10. I1 is nothing but I2 minus 3 I0 minus 12 I0 plus 10 I2. Let me simplify. 60 is equal to 10 I2 minus 30 I0 minus 12 I0 plus 10 I2. So further I can simplify. 60 is equal to, so here we have 10 I2 plus 10 I2 is 20 I2. So 30 I0 minus 30 I0 minus 12 I0 is nothing but minus 42 I0. Let me call it as equation A. So now similarly apply KVL to this independent loop I0, that is apply KVL to loop I0. So we can write 0 is equal to 4 I0. We have 4 I0 plus 2. Voltage across 2 is I0 minus I2, that is 2 I0 minus I2 plus voltage across this 10 ohm resistor is I naught minus I1, that is 10 I naught minus I1. Let me simplify this further. That is 0 is equal to 4 I naught plus 2 I naught minus 2 I2 plus 10 I naught minus 10 I1. Let me simplify. So here it is 4 plus 2 plus 10, that is 16 I naught minus 2 I2, and here we have minus 10 I1. Further I can simplify. 0 is equal to 16 I naught minus 2 I2 minus 10. So I1 is nothing but I2 minus 3 I naught. That is I2 minus 3 I naught. Simplify further. 0 is equal to, we have 16 I naught minus 2 I2 minus 10 I2 plus 30 I naught. Further simplifying, 0 is equal to 16 I naught plus 30 I naught is, we have 46 I naught, and here we have minus 12 I2, or I can write 0 is equal to minus 12 I2 plus 46 I naught. Let me call it as equation B. So now we are supposed to solve equation A, where the variables are I2 and I naught, with and equation B, that is solving equation A and equation B, we get, so equation A and B can be directly solved using calculator. Keep calculator in equation mode and choose two unknowns and feed the values. So we will get I2 is equal to 6.63 amps and I0 is equal to 1.730 amps. So this is the current I0, which is 1.730 amps. Thank you for watching.